6.6 compare and contrast functions. And this is the last lesson in Unit 6. It's a shorter unit. So being the last unit, compare and contrast functions. We already know these I-can statements right here. We already know how to do these. We have been doing them. Slide my projector over there. Okay. So basically, we have done all of these. I can tell me the slope. You can tell me the y-intercept. You can tell me if it's linear, non-linear, by a written form, by y equals mx plus b. You can determine if it is all those things by using a table. I'm losing all my little pieces here. And we know how to find them all by looking at a graph. And we know by the life situation ones verbally. Like if you were at the amusement park and the roller coaster goes up, certain one, okay, all those kind of questions, that's the verbal ones. Now today, the new one, the compare and contrast, two functions. We're going to compare looking at them all at one time, using the graph, the verbal description, the table, and the written equation. First one, example number 1. You and your friend decide to save money for a trip to Valley Fair. Oh, I love Valley Fair. Who's been to Valley Fair? Rocks. I love Valley Fair. And it costs about how much for a ticket when you go there? All-day ticket, what, 45, 50 bucks? Something like that? Well, you and your friend decide to save money during the school year to go to a trip to the Valley Fair. Your friend already has $15. So your friend is starting out with $15. So is that your friend's slope, or is that their y-intercept? Your initial amount that you start out with is 15. Your friend is $15. You have twice as much as your friend when you start out. So how much do you have?
30.
How much?
30.
30, because you take that times 2, twice as much, so you have $30 starting out. You agree to save the same amount of money each week throughout the school year. And I think there's what, like 36 weeks in a school year? Does it tell us how much you and your friend decided to save? So could we all come up with different answers for this one?
Yeah.
Yes. But just as a group, let's come up with something. What do you think would be a good amount of money that we could use for our slope that you and your friend decide to save every week? 30? $30 a week? Okay. $5? How many in here could actually save $30 a week? How many of you could more realistically save $5 a week? So you want to go with what, 5?
I couldn't even do $1.
5?
I don't have a job.
$5 a week. So what are you saving? If your friend's saving $5, what are you saving? You also, you're saving the same. You guys decided you're going to try to save $5 a week. So now we write an equation for each of you. What is your friend's equation? Y equals, now it's an equation, it has an equal sign. Y equals what?
5x.
Excellent. 5x plus 15 that he had initially. How about you? You have 5x, 5 a week, plus your initial 30 that you started with. So let's technically see how much money you guys would have at the end of the school year. Say there's 36 weeks of school. How much would each of you have at the end of the school year if there's 36 weeks? If we say that X represents our weeks, and we have 36 weeks.
180.
You get what?
180.
180, is that for you or your friend? So 180 is, you took 5 times 36 and got what? 180. And 180 plus 15 is? So your friend would have $195. How much would you have? 180 plus 30 is? What do you get?
$210.
$210. Would you guys have a good time at Valley Fair if you put away $5 a week?
Yeah.
Wow, you could buy all the Mad Hatters and all the glow-in-the-dark and all the hot dogs and funnel cakes you wanted. Yeah, that would be a nice little savings. Unless your parents helped you pay for a hotel room and gas, well then you might have to kick in a little if you save that much, right? Let's do another one. Jose and Luis each start the school year with the same number of pencils. So their initial beginning of the school year, they start with the same amount of pencils. What's a realistic number for starting the school year out with pencils? 10? Is that all you guys start out with the school year is 10 pencils? 2? 30? I would say at least that. So let's compromise. What do you guys want to come up with? 25. I like that. So that goes here, right? Or does it go here? 25. Jose and Luis both started with 25 pencils.
B.
Do they both go up $25? Is that their rate of change every week?
No.
Their initial, what they both started out with, your y-intercept. So they both started out with 25 pencils. That's what we decided to use. Now remember, when you do your homework, yours is probably going to be different than your neighbor's or my key. Because this one can be, that one can vary. In this problem, all right, sometimes it's the slope that might vary. What did Jose use for pencils? What does it say? Jose uses 2 pencils per week. So it's 2, like that, right? Ooh, I heard something that I really liked out there. I'm not sure who said it. -2. Why is his a -2? He uses. So that's taking him away. That's a decrease. So Jose has to minus 2 pencils per week. Luis uses 3 more per week than Jose. So how many does he use? He takes away 5 every week, because a -2 minus 3 more, well, that's a -5. Now I can write my equations. Y equals, everybody's equation will be the same up to the slope part here, y equals, and this one's a -5x. But now in your homework, some of you will have different initial starting points. But we decided that we're all going to start out at 25 as a class. All right, letter C. You have an elm tree sapling, a little tiny tree starting to grow, and an oak tree sapling. They are the same height when they're planted. The elm tree sapling grows 20 inches per year. The oak tree sapling grows 13. Is that a plus or a minus? It's a plus. They're increasing in size, so they're positive numbers. So where do we want to put that 20 and that 13? Is that their initial height? Is that what they started out as?
No.
No. But the elm tree, the rate of change, it's a positive, goes up how much every year?
20.
Goes up 20 inches per year. The oak tree goes up what? 13 inches per year. That's the rate of change for the oak tree. Now what was the initial height of both of them when we planted them? They were both the same.
We don't know.
We don't know, so this could vary. What do you want it to be?
5.
We're talking inches, like a little teeny sapling. How big do you want it to be?
5 inches.
So I would have gotten some answers with 2, 5. Okay, we'll go 5 inches. Little teeny sapling. So now let's do the math. The equation would be y equals what? Yep, 20x plus 5. Y equals 5x plus 13. I have a mistake. Find it.
13x. Yeah.
Where's my mistake?
You just switch the 3 and the 13 and the 5.
Right. This should be 13x. My y-intercept is 5. Okay, now here's where the compare and contrast comes in. We want to find similarities and differences. Contrast, differences. We have a graph, A. We have a table, letter B. We have a written example, the equation C. And D, we have a verbal description. On your boards, hold up, label them so I know which is which. Your M, what is your M for A, and what is your B? Hold up your answers for your slope and your y-intercept for that graph. All right, if you haven't gotten it, look it up here, letter A. Well, on my y-axis, I can see right here that my B, my y-intercept is a -4. My slope, if I pick 2 points, any 2 points on here, rise over run, I run a +2, that goes on the bottom. I rise a +1, so my slope is 1/2. All right, do B, hold up your slope and your y-intercept for B, please. This one you had to work backwards now. What did I have to do to get from 3 to 2?
+1.
3 to 2, we did what?
Oh,
-1. What did I do to get from 13 to 10? I'm -3. So y over x, a -3 over a -1 simplifies to what for my slope? Negative divided by a negative is a +3. So my slope is a 3. Now what follows the 0? We need to find this. Well, what's 10 minus 3? 7. 7 minus 3? 4 minus 3? 1. So my y-intercept is 0 and 1. How about C? Hold up your slope. This one's super easy. Yes, good. I'm seeing the answers fly right now. Awesome. Perfect. Doesn't get much easier. What's with our x? Our slope is 1/2. Our y-intercept is 1. All right, how about here? Pretty much tells you in a verbal description. A linear equation with a rate of change of a -1. So what is that? Yes, perfect. I'm seeing them out there. Very good. Rate of change is the same as your slope. And the initial value, what we started out with, the initial value on that y-axis where we started out with was a -6. Now we got to answer the questions. A, B, C, and D. A, B, C, and D. Letter A asks us, which 2 representations, so hold up on your boards, which 2 have the same slope? Out of the A, B, C, and D, which 2 have the same slope? As soon as we have 100% accuracy, we'll go to letter B. Correct, it is A and C. The 1/2 and the 1/2. Those 2 have the same slope. Letter B, which 2 have the same y-intercept? You're all correct. It is B and C. They have the same y-intercept, which is they both have the 1. Letter C, which has the lowest y-intercept? How low can you go? Which has the lowest y-intercept? Majority rules. How low can you go? It is D. This one goes to a -4. That one's a 1, but this one goes way down here to the -6. So it's D. How low can you go on the y-intercept? And D, which representation has the steepest slope? Which one is closest to being vertical? Would it be the -4, the 1, or the -6? We know this one's what the -4 looks like. If you're not sure, if you started at the origin and did one that's 1 and 1, it would look something like that. So out of those 2, which is steeper? 1/2 or 1? Which is steeper? 1/2, the slope of 1/2, or the slope of 1? Oh, whoops, this was a -1, Mrs. Lennon. It should have went this way. Not that one. Which one has a steeper slope? 1/2 or a -1? Which is steeper? The -1. So that means, which is it going to be? What would a -4 slope look like? Start here, right 1, down 4. Left 1, up 4. That's what this one would look like. Oh, I see people wanting to change their answers after that. So which one is the steepest? That line B. All right? Or line, which line is this one? Did I do 4? I was supposed to do 3? Oh, I'm getting all mixed up, Mrs. Lennon. I'm doing my positive and negatives all backwards, not even on purpose. Sorry about that. The 3, right 1, up 3. There we go. Left 1, down 3. There we go. The letter B. 3 is the steepest. So B's out there as the winner. All right, one more page, or one more example, and then we'll get to our homework. Okay, find them. I'm going to give you a couple minutes. Find your slope and your y-intercept for all four. For the A, the B, the C, and the D. All right, now you've had time. Let's see what you came up with. The majority, what do you say my slope is here? What does it change? A -5. It decreases 5% per hour. So your slope is a -5. What was its initial? What did we start out with? 100. Now over here, what's my slope? What did I do? Get to here, I did what? I added 2, and to get from here to here, I subtract 1. Is it 2 over -1 or -1 over 2? Y over x, rise over run, so 2 over -1, which simplifies to -2. What's my y-intercept? Oh, 4, 3, 2, 1, 0. Well, I'm plussing 2. 3 plus 2 is plus 2, plus 2, plus 2, and plus 2. 13 should be your y-intercept. Here, it doesn't get much easier, a -5 and 13. And here, the rate of change, meaning your slope, -6. Initial value, what did you start out with? The y-intercept is a 5. Now let's answer. A, B, C, and D. Board's ready. A, B, C, and D on the bottom of your worksheet here. For letter A, which two have the same slope? Nice. Seeing all right answers. Which two have the same slope? A and C. B, which two have the same y-intercept? Whew, just flashing those answers. They are. It is B and C. How about C? Which representation has the lowest y-intercept? How low can you go? Oh wow, no questions on this one. It is D. 5 is, oops, yeah, the lowest y-intercept. Is that one right? The lowest y-intercept. 13. Oh yeah, because these are all positive. I was looking at the negative. So that one's way up there, 100, and then these are at 13. This one's down at the 5. And D, which representation has the steepest slope? Again, I'm seeing D, which is correct. A -6, that's going to be straight more up and down than the -5. Your homework. You need to do the pages 5 through 8 in your packet. 1 through 5 and 8 through 9. So basically pages 5 through 8, but you can skip number 6 and 7.